The weight driver is a cone-based vector node, which outputs a value based on the direction of the target object. The value can then be used to drive corrective shapes. This gives a much more predictable result than relying on rotation values alone, which can be quite different even if the pose appears to be the same. The character in my scene has his arm posed, with keyframes at frame 1 and frame 20. The pose is the same at both frames, but the animation in between indicates that the two poses are different regarding their values. By selecting the upper arm joint and viewing the rotation values in the channel box, we can indeed see that these are different for the two keyframes. This behavior makes it rather useless to have corrective shapes being driven by rotation values of joints or other nodes if more than one axis is involved, only because the same resulting pose can have a different combination of axis values. This is true for joints rotating on 2 or 3 axes, such as the shoulder, wrist or hip. The bending of the elbow is usually not a problem because the rotation involves only one axis. The general solution to the problem is a cone-based vector reader, which compares two vectors and outputs a value based on a given range. Let's take a look at how such a node as the weight driver works. The elbow area of the bent arm needs a corrective shape which should be driven by the rotation of the lower arm. The green arrow indicates the vector of the lower arm, which points to the wrist and changes when the arm is bending. The red arrow defines the goal vector, at which the corrective shape for the elbow should be triggered with a value of 1. The yellow cone represents the range within which the corrective shape value should blend from 0 to 1. At the default position, the green target vector is outside the given range, and the resulting value is 0, which means that a corrective shape does not get triggered. But when the arm starts to bend, this target vector eventually reaches the boundary of the given range, the yellow cone, which means that this is the farmost angle at which the direction is considered in relation to the goal vector. From here on, the output value increases from 0 to 1, the closer the target vector gets to the goal vector. If finally the target vector matches the one expected by the weight driver node, the output value equals 1. Since most attributes and especially blend-shaped targets work in a range between 0 and 1, this output value can be directly used. Since of course the arrows in cone aren't the weight driver and are only for visualization, let's add an actual weight driver node to the scene to make the corrective shape work. I go to the point where the corrective shape should be active. The shape already exists in the target list. Since we want to use the weight driver node, which is disabled by default, I first need to go to the Preferences and from the UI Elements tab activate Weight Driver. The driver type list now contains a weight driver entry. The driving node, the lower arm joint, is already listed in the driver list. Selecting the joint in the list now displays the attributes of the weight driver. The parent joint field contains the parent joint of the selected joint. This is the joint the weight driver gets parented to, because its rotation must be independent from the lower arm rotation. Of course, you can also select any other node if needed. The axis gets automatically set to the aim axis of the joint, or in other words, the axis at which the next child joint can be found. With the default Maya joint orientation, this is the x-axis. The range defines the angle between which the output value blends between 0 and 1. Since the current rotation of the lower arm is set to 80 degrees, this gets automatically set as the value the blending begins to start. At the other attributes we will look in a minute. With all the settings in place, I click the Shape Driver button in the target list to create the weight driver setup. You can immediately see that the target shape gets activated with a value of 1 and a weight driver node appears in the scene. It's named after the blend shape node as well as the driving shape and also displays the output value. If I now rotate the arm, you can see that the value constantly changes depending on how far the vectors are apart. In the outliner we can see that the weight driver node is parented to the upper arm joint and that a hidden locator is placed underneath the lower arm joint, positioned at the wrist. This locator defines the target vector for the calculation. The weight driver has several attributes to control its behavior. The most important are the direction and if the axis is inverted or not. We also have seen the angle, which defines the range of the blending. It's also possible to include a twist calculation if needed. The center angle defines how broad the center range is for outputting a value of 1. The interpolation defines how the values are interpolated between 0 and 1. Switching back to shapes, you can see, after selecting the target shape, that the changed values are directly reflected in the Shape Driver folder. All attribute changes made here are immediately applied to the weight driver node in the scene. But let's take a look at how the weight driver works in our first scene. I quickly set up a weight driver for the arm rotating down. The driver is the upper arm, in this case the joint aim axis is the negative z-axis, indicated by the negative rotation value. With the weight driver in place, we can directly see how the shape is being driven. Let's go to the frames which show the same pose, but where the arm joint has different rotation values. Even though both keyframes feature different joint rotations, the output value of the weight driver is the same, which makes the result even more predictive than relying on rotation values alone. Since the weight driver is a plugin, it needs to be present whenever a scene gets loaded which contains the node. So it's not only needed for creating the rig, but also if it should be played back or rendered. But contrary to the Shapes plugin, the weight driver plugin is a free node and can be installed without restrictions. You can download it separately, or you can find the multi-platform zip file in your Shapes installation folder in your Maya user preferences. This way it's easy to pass it on to colleagues or customers which don't have Shapes installed, but need to work with a scene containing the weight driver node.